All right, here we go. So 3-2 last time we had a video problem. We were in 4K, is that right? Yeah. We had a 4K video, all right, but it ran out. The time ran out. So because it was so, and so now we got that fixed. But I went ahead and recorded myself in my office the end of section 2. That will be coming out this week. So I got most of section 2, I think, in class, but there's a few of those on the end. If you didn't get, can't figure out, that'll be on the video. That'll come out pretty soon. Okay, so we're going to go ahead and do 3-3 today and hopefully 3-4 if we can get to all this today. All right, so what we did in 3-1 and 3-2 was we found the derivative using the limit, right? And remember the last thing in 3-2, we took the limit as h approaches infinity of f of x plus h minus f of x over, h minus x or x minus h. And we got divided by x plus h minus x, which is h on the bottom. So we did all of that limit and we got the derivative, right? Okay. There's much easier ways to do it. Okay, so but now that's the definition, and then we have to understand the definition to know really what we're doing. Okay, so we've done that. Now we're going to learn rules for doing the same thing except a lot easier, a lot quicker. Okay, so just a few rules here. We'll look up here real quick. Hopefully you can see this. All right, so some theorems. Okay, constant rule. If you take the derivative of a constant, what does that always give you? If I have y equals 2, that's a line, horizontal line. Remember, the slope of a tangent line of a line is the same as the slope of the line, right? So what is the slope of a horizontal line? 0. So the derivative of a constant is always 0. Okay, so anytime you got derivative of a constant, it is 0. Okay. Power rule. All right, power rule is about all that we're going to be doing in this section right now. And really these two sections is really just the power rule. Now the way the power rule works, if you've got, say, f of x equals 2x to the third power. Okay. If I want to know what is the derivative of that, and remember, this is the notation there with a little prime symbol, right? All you do is take the exponent, multiply it times the coefficient. 3 times 2 is 6. And then subtract 1 from the exponent. 3 minus 1 is what? There you go. Okay? Now, last time to do that problem, I filled up the board, right, with the limits. Okay? That's all you got to do. Okay? So this is the derivative of that. So this will produce the slope of the tangent line at any point on this graph. Okay? Questions about that? Okay? Now this is in Moodle too. These are all in Moodle. So just remember that if you ever want to print these off or need to pull them up, it's all in Moodle. All right, let's see. All right, let's go on through. Okay, so constant multiple rule. If f is differentiable at x and c is a constant. All right, all this is saying is if you've got a constant times a function and you're going to take the derivative, it's just that constant times the derivative of the function. That's it. Okay, so that's all you do there. All right, the sum rule. Okay, very important. Okay, if you've got some function plus another function, or some function minus another function, then the derivative of that sum is just the derivative of the first one plus the derivative of the second. All right. Addition, subtraction, you can do that. Okay, so I can just take the derivative of the first one plus the second. It does not work with multiplication and division, though. Okay, so in the next section, we're going to have a product rule and a quotient rule for derivatives. And we have to have a rule for that. It doesn't work that simple. Okay. Now again, like I said before, limits, it does work with limits. With limits, you can add them, you can subtract, you can multiply and divide, and it works. It does not with derivatives. Okay. So Addition and subtraction, you just take the derivative of the first plus derivative of the second, and that's good. If we're multiplying and dividing, though, that doesn't work. All right, questions about that? All right, we're going to throw one at you here. All right, derivative of e to the x. So remember, e is the base of exponential function. The inverse of that, remember, is the natural log. So it's a log with the base of e. So the function f of x equals e to the x. That derivative is just e to the x. Okay? All right. Yes, that's the thing to remember. The derivative of e to the x is what? You already forgot it? Is what? E to the x. There you go. Yes. All right. So to remember, that could be on the quiz. What's the derivative of e to the x? E to the x. Okay? Questions? If you want to know why, talk to me later. We can. All right. All right, last thing, then we'll do some problems here. All right, the prime notation. So here's just some notation things again with derivatives, okay? Now, we use normally the prime, double prime, those, and then the dy dx notation. Okay, so here are, if you've got a higher derivative, all right, so like if you take the second or third derivative, that kind of thing. All right, so notice the prime notation, f prime, f double prime, f triple prime is typically used only for the first, second, and third derivative. So you don't add another prime if you go beyond the third derivative. It's just those three. And a lot of texts will not even use that one. They'll put a 3 up there in the place for third derivative. But anyway, parentheses are placed around n to distinguish a derivative from a power. So if you've got a higher derivative, you just put the number of the derivative there in parentheses. And those parentheses distinguish that from an exponent. Okay? So if I have an f with a 4 up there in parentheses, that's the fourth derivative of f. All right. F0, that would, by convention, is the function f itself. All right. So other notations for second derivative. Okay. If you have dy dx, that would be the notation for the second derivative of y. And if you did the second derivative with f, you could write it with an f there. And that comes from this. So this notation comes from taking the derivative with respect of x of df dx or dy dx. So if you think about just putting those together, that gives you d2f dx2. All right, questions about that? And then you could do that. Use that notation with any derivative. You could do, if you did third derivative, you could put 3 there and a 3 there. Fourth derivative, put a 4 and a 4. All right, any questions about that? Okay. The rest of it is let's find some derivatives. It's not good if you break the rules, all right, because you're going to miss the problem probably. So follow the rules. All right, so y equals x to the fifth. All right, the derivative, so notation-wise, let's do y prime, okay, equals. All right, x to the fifth, all we know is the power rule, right? And it's a power. So I say 5 times 1 is 5. Subtract 1 from the exponent. 5 minus 1 is 4. 5x to the fourth is the derivative of that. Questions about that? Okay. If I have f of x equals 5. 5 is a constant. What's the derivative of a constant? 0. Okay. G of x equals e to the third power. I'm trying to trick you on this one. What would the derivative be of that one?
E to the third.
That's what you might think. They're trying to trick you though. What? Okay, the derivative of e to the x is e to the x. This is e to the third. Okay, so is the independent variable e here? Independent variable is x. So if it was x to the third, or g of e to the third, where e was variable, you could do that. But it's not. Anybody else? Well, what is e to the third? What is e? What's the number e? Around 2.71 something, all right? So if I raise 2.71 something to the third power, whatever that is, right? But what do I have? What is this actually? A constant. What is the derivative of a constant? 0. All right, so that's 0. All right, questions? Okay, let's see. All right, let's skip to this one. All right, f of x equals, v. And they will use some different variables here, and that's fine. And just like on that one, remember, think, what is the independent variable? Okay, the dependent variable is, we always think of that as just y, whatever the function value is. Okay, what would be the independent variable here? Right there, b, right? Up here it's been, well, x, x, x. Here it's v. So treat v just like you would x with our rules, right? So v to the 100 power rule, all right? So derivative would be multiply by 100, subtract 1 from the exponent, 100 v to the 99 power, all right, plus, now remember this is a sum. So remember with sums, with the derivatives, you just take the derivative of the first, plus derivative of the second, plus derivative of the third. What is the derivative of e to a x to a power of a variable power? The derivative of e to x is what? E to x. So if it's e to the v, it would be what? E to the v. 10 is a constant. Derivative of a constant is 0. That is your derivative. Okay? Questions? If I have g of t is equal to 6 root t. Okay, again, all we know is the power rule. Okay, so we need to think in powers. If I've got square root t, can I write that as a power? Yes. What is square root? What's the power for square root? 1/2, right? So I can do 6t 1/2 power. That's the same thing as 6 square root t. Okay. Derivative. All right. Multiply. 1/2 times 6 would be 3. Subtract 1 from the exponent. 1/2 minus 1. Negative 1/2. All right. Normally we don't leave negative exponents in the answers. It's okay for E. And I think your book, they may start leaving them. I mean, it's really not that big a deal to have a negative exponent. But at this point, usually we do go ahead and get rid of the negative exponents. Now, it'll get to a point to where, a few more courses down, you'll just say, forget it, because it's not worth fooling with. But just move it to the bottom, and then probably could write it like that would be good. Okay? Questions about that? All right, let's say f of x equals 10x to the 4th minus 32x plus e to the 2nd. Okay. All right, so we're going to take the derivative. All right, power rule. 4 times 10 is 40. Subtract 1 from the exponent. 4 minus 1 is 3. Okay. Now, if I have 32x, if I multiply 1 times 32, I get 32. Subtract 1 is 0. X to the 0 is what? It's what? 1, right? So that's just negative 32, right? What is the derivative of e to the 2nd power? What? 0. Yes, good. Only fooled you once. That's good. All right, you're bright. Okay, questions about that? I'm going to put the two up here I want y'all to do first here. All right, let's see. First one, I would change that to a half first. Okay, right? And then these are all just, this is polynomial, just a polynomial expression. So derivative of the first one, 1/2 times 4, half of 4 is 2. And then 1/2 minus 1 to the negative 1/2, right? 4 times times a fourth would be 1. And then subtract 1 from the exponent's 3. What's the derivative of t? 1, right? What is the derivative of 1? 0, all right? So then just fix that negative exponent there. So you could have this. That should be a good answer there, okay? Questions about that? All right, this one, derivative. Okay, e to the x. What's derivative of e to the x? E to the x, all right? I've got a constant times e to the x. So remember with one of our theorems there, it's just a constant times the derivative. So that derivative is just 3 e to the x, okay? 5x, what's the derivative of that? 5. Derivative of 5 would be 0. So there you go. All right, any questions about those? Okay. All right, find the derivative of the following functions by expanding or simplifying the expression. All right, let's just look at a couple of these. Now notice this is a product. You've got a trinomial times a binomial. All right. Now we will learn a rule in the next section really quick called the product rule, where we could use the product rule to multiply these. All right. We don't know that right now though. Okay. So we can though just expand that out and use our power rule that we know. So if we do that, algebraically we'll need to distribute this out. So take everything on this first one and distribute to the 2 on the second. So we would get, and now you might want to combine terms and get 5r the fourth plus 3r cubed, and then 15 and 1 would be 16r squared plus 9r plus 3. Okay, now is that my answer? No, I'm finding the derivative. I just reduced it, that's all I did, right? So now we just have terms added together with powers. So we use our power rule. So I'll say the derivative with respect to r. All right, so I'm going to say 4 times 5 is 20. And then subtract 1 from the exponent. That'll be r to the third. Okay. 3 times 3 is 9. Subtract 1 from the exponent, I get 2. 2 times 16 is 32. Subtract 1 from the exponent, I get 1. And then 9r, the derivative is 9. Derivative of 3 is 0. There you go. Okay. Now again, and that's a quotient, right? We don't know how to do quotients with derivatives. We will learn it again in the next section where we have a rule for that, but we know how to do powers. So since you've got 2 terms on the top divided by a single term, you can break that apart like that, right? That means each of the ones on top would be divided by w, and then this will reduce to be w squared minus 1. Okay? Now, derivative of that. W squared will be 2w. What is the derivative of 1? 0. All right? 2w. Now, one thing that you need to watch on this one, when is a function not differentiable? Remember that from last time? Wherever it's not continuous was one time, right? where is this function not continuous? When w is what?
0.
0. Right. So let's say derivative of f with respect to w is 2w x4 w not equal to 0. Okay, because at 0 it is not differentiable. So 0 is not going to give you the derivative. Okay. Now, later on in the chapter, we'll learn something called chain rule that we could use to integrate that to differentiate that quickly. All right, we don't know how to do that yet, though. So, but we can expand this. So remember, to expand it, you just need to write the binomial out twice, and then distribute it out. So this would be x to the 4th plus x squared plus 1. And then that would give me x to the 4th plus 2x squared plus 1. H prime of x then would be 4x cubed plus 4x, and then the derivative of 1 is 0. That's your derivative. All right, any questions about that? Now again, if we knew the quotient rule, we could use quotient rule and figure it out, okay? But we don't know that. All right, so it had to be powers if we can differentiate it. They're not going to give you a problem that you can't differentiate now. All right, so what can we do to that algebraic expression to work on it a little bit? Top is a difference of squares, so if you factor the top, you get this. Right, and then you notice the x minus 1s then would divide out. So this function is really just the line y equals x plus 1 with a hole in the graph at when x is 1. Right? So do the derivative of that. What is the derivative of x plus 1? It is just 1. Right? Because if you have x, you multiply 1 times 1, you get 1, minus 1, 0. And remember we said before, if you've got a line, the slope of the tangent line is always the slope of the line. Well, the slope of the line is 1, slope of the tangent line is 1. Okay? But just like the one we did before, this one, where is that not differentiable? When x is what? 1. Right? So here I need to say for x not equal to 1. So what about that one? Any idea what we could do to that to be able to reduce it, simply change the way it looks so we can integrate? And a is just a constant. So a represents any constant. Any idea what we could do?
Just change the square roots to x 1/2 and a minus a 1/2.
Okay.
The power rule.
Okay. Well, you got division in there. So you got the top divided by the bottom. So you can't do just derivative of the top divided by derivative of the bottom. That won't work. Okay, because now if we knew the quotient rule, we could do that. We don't know it yet though. There's a way we can do this one without knowing it though. How can we simplify? What else? What could we do to simplify? What do we do with the limits when we had a square root in it? What do we do? You already forgot. What did we? Multiply the top and bottom by the conjugate. All right, that'll work on this one. Okay, I'm going to show you 2 ways. That's one way to do it. So you can multiply the top and bottom by root x plus root a, and that's probably how you would choose to do it. All right, so if you do that, all right, then the bottom. Okay, so the bottom would be. Or where the conjugates are, right? So we would say root x times root x is x. And your middle terms will subtract off. Negative root a times root a is minus a. On the top, just leave it x minus a times root x plus root a. All right, everybody follow that? Same thing we did with the limits before. Now you can divide those out, and that is equal to root x plus root a. Okay? And now that you can do the derivative of. Okay? Because this is the same thing as x to the 1/2. Now root a represents what? Just a constant. So it really doesn't matter. The derivative then would be 1/2 times 1. X 1/2 minus 1 is negative 1/2. And then the derivative of a constant is just 0. So you could write this as negative 1 over 2 root x. Okay? Now, what can x not be on this one? When is this one undefined? When x is what? The bottom can't be 0. What do I put in here for x to make the bottom 0? Not 0. What minus root a gives you 0? A, root a, right? So x would be a. So whenever x is a, whatever a is, it's undefined. So I need to say over here if a does not equal x. Okay. Questions about that? Now, another way on that one, I'll just show you what you can do to simplify it. If you notice, okay, so look, everybody look. Notice up here, for this difference of squares, you had x squared and you had x on the bottom. You had 1 on the top, square root 1 is 1. All right, well notice here you've got x, square root of x is root x, a, square root of a is root a. This you can, did I write that down right? This should be a minus, sorry. The top is it can be like a difference of squares. I can rewrite the top like this. Okay, see that? This is just like doing this, right? Because up here when you take a difference of squares, you're just taking the square root of x, which is x, and writing it there and there. Square root 1 is 1, put that there and there, plus minus. Same thing here. You've got the difference of x and a, so that can be rewritten as square root x, square root a, minus plus, and then that cancels and you just get, oh, sorry, wrong one. These cancel and you just get root x plus a. So either way, you get the, can reduce it. So, all right, any questions about that one? All right, f of x equals 2x cubed minus 3x squared minus 12x plus 4. All right, two questions here. A part, find all points on the graph of f at which the tangent line is horizontal. Okay, and then B part, find all points on the graph of f at which the tangent line is has a slope of 60. Okay? So we got a function. We want to know first the points on the graph of f at which the tangent line is horizontal. All right, so when it says all points on the graph of f of x, the points, that would be your x, y points, right? Okay, see that's what, yes, xy points. Points where the slope of the tangent line would be 60, all right? So in order to do that, first we have to find the derivative, because the derivative produces the slope of a tangent line at a point. So if I take the derivative of this, I will get 6x squared minus 6x minus 12. All right, we know how to do that easy now. Okay. So the A part, find all points in the graph of f at which the tangent line is horizontal. Where would I find, how would I find the horizontal tangent lines? What would the slope be? Horizontal line, what's the slope? 0. Set the derivative equal to 0. When is the slope 0? Okay. Solve that quadratic. Now, to solve it, I just divide both sides by 6 first, because 0 divided by 6 is still 0, and that's going to simplify it a bit. So, if I divide both sides by 6, I get that quadratic. Okay. Now, factor it. Minus 2 plus 1 gives me the negative 1 in the middle. So x is equal to negative 1, x is equal to positive 2. Okay, so when x is negative 1, when x is positive 2, that's where I should have horizontal tangents. Okay, what are the points though? Well, I would have negative 1 and I would have 2. Okay, where do I go to figure out what to put in here? Where do I plug in negative 1 at? Do I plug it into the derivative or do I plug it into the function? What do you think? The function, right. Okay, so take this, plug it into the function. And that, because I'm looking for a point on the graph, right? Put negative 1 back in for x, for all the x's. Add that up, you should get 11. All right, plug in 2 into the function, you should get negative 16. So those 2 points on that graph should be where you would have a horizontal tangent. Okay. Graphically, what should you have there if you have a horizontal tangent? So like if we were to go over there, and I'm going to go over a minute and graph it in Desmos. If when I do that, what am I going to see at negative 1, 11 and 2, negative 16, you think? What does it look like when where you've got a horizontal tangent, you think? Where you've got a what? Curve. It should be a curve. You should either have this, like that there, or like that, right? Should be at those points, all right? So let's see. Okay, so he said at negative 111, all right, notice right here, negative 111, horizontal tangent. That looks right. Okay. At 2, negative 16. There you go. Got a horizontal tangent. Looks like we did good. All right. Questions about that? Okay. The other question said, find all points on the graph of f at which the tangent line has slope 60. Okay. Well, here we want the slope of 60. Well, do the same thing I did there, except rather than putting a 60 here for the derivative, put 0. Rather than putting 0, put a 60. So let's do 60 equals 6x squared minus 6x minus 12. Okay. Now I'm going to solve that for x. So again, I can divide both sides by 6. I get that. And then subtract the 10 from both sides because it's got to be equal to 0 for me to be able to solve it if it's quadratic. Factor looks like it's when x is at negative 3 and x is equal to 4. Is that 4? All right. So The point should be -3. If I plug -3 back into the function, I will get -41. If I plug 4 into the function, I get 36. All right, any questions about that? Okay, this says find first derivative, second derivative, third derivative of these functions. Let's do 2 of them. Well, we'll do all 3. All right, let's see. F of x, these are not very much to them. Just polynomials are pretty simple. All right, these get complicated. We can make them more complicated, but these are not too bad. All right, so first derivative would be, let's use the power rule. 3 times 3 is 9. Subtract 1 from the exponent, I get x squared. 2 times 5 is 10. Subtract 1 from the exponent, I get 3. 1 times 6 is 6. Subtract 1 from the exponent. Whoops. 2 minus 1 is 1. 6. All right, so that should be it. 9x squared plus 10x plus 6. Okay, questions? Second derivative, just take the derivative of the first, and that'll be the second. All right, so 2 times 9, that'll be 18x. And then I have 10, and then the derivative of 6 is just 0. Derivative again. 18, derivative of 10 is 0. All right, there you go. The first 3 derivatives. Questions about that? So just like the ones we did before, you know, we don't want to do a quotient yet, but we can reduce that. We can factor and try to reduce. So if you do that, minus plus, so minus 8 plus 1. That's how that would factor, right? And then the x plus 1s would divide out. So I get f of x equals x minus 8. So that is just a line with a hole in the graph at -1. Okay? So the first derivative of this, what's the derivative of x? 1. Derivative of -8, 0. So I just got that. Now, what is the derivative of 1? It's constant, so 0. What's the derivative of 0? 0. Probably should say for when x is not equal to 1, too. Okay. All right. What if I have f of x equals 10 e to the x? Okay. What would the first derivative of that one be? What's the derivative of e to the x? E to the x. I have a constant times that, so just bring the constant down. I get 10 e to the x. What is the derivative of 10 e to the x? It's still 10 e to the x, right? Third derivative. Still going to be 10 e to the x. All right. Questions about that? Last thing, there's a graph up here we want to look at. All right, so look at this graph up here on the screen. All right, notice the directions say, let f, capital F, be lowercase f plus lowercase g. So the black graph here is f, the green or the red graph is g. Okay, and then capital G would be 3f minus g, where the graphs of f and g are shown in the figure. Find the following derivative. So if I want to know what is the first derivative of capital F at 2, all right, how do I figure that out? Can y'all see when I write right here? If I push this back, can y'all see over there? Maybe? Okay. Well, it said f, capital F, is equal to lowercase f plus g, right? So what would the derivative of capital F be? I've got a sum, so what do I do with the sum with derivatives? Derivative of the first plus derivative of the second, right? Or the derivative of the first one plus derivative of the second one, yeah. So I have that, right? So F prime at 2, capital F prime at 2, should equal the derivative of F at 2 plus the derivative of G at 2. All right? Does that make sense? Well, what is the derivative of F at 2? Well, 2 is here. Here is F. What would the derivative be at this point? Well, what's the graph here? What is that? It's a line, right? If you get, what's the derivative of a line? The slope of the tangent is the slope of the line, right? So at 2, what is the slope of this line here at 2? Well, I got a point here and a point here, looks like. So down 3 to the right 1. What's the slope? Negative 3 over 1, which is negative 3. F prime at 2 is negative 3. Does that make sense? At 2, G prime at 2. All right, well, here is that. What's the slope of the line right there we're at 2? Up 1 over 1, slope of 1. Negative 3 plus 1 is what? Negative 2. So F prime at 2 is negative 2. Okay? Questions? All right, G prime at 5. Okay, I need to erase all this. All right. Messed my hands all up here. All right, they told us G, capital G, was 3F minus G, right? All right, so the derivative of G then would just be, you just got a constant times a function. So it's just 3 times that F prime minus G prime, right? All right, so here then, G prime at 5. All right, so that's going to be the same thing as 3 times the derivative of F at 5 minus the derivative of G at 5. Okay? 5 is here. All right, so first is F. All right, there you are on the function F. What is the slope there? What's the slope of the line? One? Is that what you're doing? Okay. It's all right to talk. It's all right to talk. Okay, yes, 1. All right, so that's 1. All right, the red one. What's the slope right here on the red one? Down 1 over 1, negative 1. All right. So I've got 3 times 1 minus negative 1. So that'd be 3 plus 1. That is equal to 4. All right, any questions about that? Okay, that is section 3.